All right, today we're going to be using geometric means to find segment lengths. So the first rule for today is going to be the length of the altitude to the hypotenuse. Hypotenuse, the length of the altitude to the hypotenuse is the geometric mean of the two segments it creates. The length of the altitude to the hypotenuse is the geometric mean of the two segments it creates. So in a right triangle, this blue segment that goes to the hypotenuse, the altitude to the hypotenuse, it creates another 90-degree angle. But it also creates two segments of the hypotenuse. And we're going to call this one X and this one Y. The entire hypotenuse we'll call C. The altitude will be H. The left leg of the original triangle is A, and the bottom leg was B. So the length of the altitude to the hypotenuse is the geometric mean of the two segments it creates. So this segment H, when it got added to this diagram, it created segment X and segment Y. So H squared is equal to X times Y. And another way of writing that is that H is equal to the square root of XY. Those are both true. So the length of the altitude is equal to the geometric mean of the two segments that it creates. Okay? Second rule in this section. The length of a leg of a right triangle so in this case, you're talking about A or B. The length of a leg of a right triangle is the geometric mean of its adjacent segment of the hypotenuse and the hypotenuse. So here's what that means. The length of A, all right, they're saying that A squared is equal to x times c. It's adjacent segment of the hypotenuse and the hypotenuse. So x, c. Or another way of writing that is that A is equal to the square root of x times c. Both of those are true. And that B, see the pattern? A is equal to, or A squared is equal to, x times c. So what would B squared be equal to?
Y times C.
Y times c, right?
Yeah.
And another way of writing that is that B is equal to square root of y times c. Now, some of you are better at remembering words and formulas. I'm better at remembering like pictures. So the pictures that I can remember is that H is the geometric mean of these two pieces that it creates. See how that forms a big T? I can see a T there with the hypotenuse and the altitude. So the leg of the T is equal to the geometric mean of the two tops of the T. That this side of the right triangle is equal to the geometric mean of the piece closest to it and the hypotenuse. That this side of the triangle is equal to the geometric mean of the piece closest to it and the hypotenuse. So if you want to flip the page and look at example 3, we're going to use this information to find some segment lengths. So there's a right triangle on that page that looks something like this. The big triangle's right angle is right here, and the altitude to the hypotenuse is right there. The segments are labeled Z. The altitude is X and Y. The two segments of the hypotenuse are 2 and 10. So there's two ways to find x. The easiest way to find x here is that x is equal to the square root of 2 times 10. Which is equal to the square root of 20. So in simplest radical form, you're going to factor this square root of 20, or you're going to simplify it. And that's the square root of 4 times the square root of 5. The square root of 4 is equal to 2, and this simplifies to 2 radical 5. Now, to find these legs of the right triangle, you're going to need the length of the hypotenuse. So now you can just combine the two segments, and the hypotenuse of the big triangle is 12. So Z is going to be equal to the geometric mean of its adjacent segment of the hypotenuse and the hypotenuse. So Z is going to be equal to the square root of 24. When you simplify the square root of 24, four and 6, right? So square root of 4 times square root of 6. And that simplifies to 2 square root of 6. Same rule for y, but on the other side. Y is going to be equal to the geometric mean of 10 times 12. Its adjacent segment of the hypotenuse and the hypotenuse. So that is the square root of 120. And again, the largest perfect square that goes into 120 evenly is going to be square root of 4 times the square root of 30. Which is 2 radical 30. A radical is in simplest form when it has no factors that are perfect squares. A radical is in simplest form when it has no factors that are perfect squares. That means there are no perfect squares that will go into 30 evenly. Any questions? All right, one more example, and that's the check it out. Right below example 3 on page 536. A little different use of the rule. Your segment lengths in this diagram, U, W, the altitude is 9, 3, and V. All right, this is a case where I gave you two formulas for the altitude in each of the legs. So in this case, this altitude, 9 squared, is going to be equal to 3 times U. And if you square the 9, then 81 equals 3 times U.
Wait, why would it be 3 times U?
Because there was two formulas for the altitude. One of them was that 9 equals the square root of 3 times U.
Right.
And the other one was that 9 squared equals 3 times U. In this case, when you know the length of the altitude, this formula is easier to use because you don't have to square both sides first. So over here, if you divide both sides by 3, then 27 is equal to U. In the last problem, you had to find the altitude, and you were given this segment. So this was an easier formula. So now if U is equal to 27, the entire hypotenuse is equal to 30. So if you're solving for W, then W is going to be equal to the square root of its adjacent segment, which is 27, times the hypotenuse, which is 30. And 27 times 30 is equal to the square root of 810. The largest perfect square that goes into 810 is the 81. So that's the square root of 81 times the square root of 10. And that simplifies to 9 radical 10. V is going to be equal to the square root of 3 times 30. So V is going to equal the square root of 90, which is the square root of 9 times the square root of 10. And simplified, that would be 3 radical 10.
Wait, so why does V equal 3 times 30?
Because of the rule that the leg of the triangle is equal to the geometric mean of its adjacent segment of the hypotenuse and the hypotenuse. Same reason that W was equal to the square root of 27 times 30. V is equal to the square root of 3 times 30. Any other questions? Your assignment for today is on page 537. Problems 11 through 13, 11 through 14, and 24 through 26. (11 through 14) and 24 through 26.